Today we're talking about the complex numbers, and so a lot of the stuff that we're going to do today can be done in the calculator, a lot of it, and that's one thing that we're going to work on. I'm going to do the first question the long way so you can see it out, and from there on out, we will move back and forth between it and the calculator. The square root of 25. Now I told you a shortcut like maybe a week ago for what you're supposed to do. You're supposed to take the negative away and put an I, right? Okay, I want you to understand what that symbolizes. The square root of -1 is really what I symbolizes. Instead of writing this out, we use just one letter. It's more efficient. Okay? And so really what this is this is I. What's the square root of 25? Okay. So really this is just 5I. And that's like the new stuff part of the new stuff we're going to do today. So square root of 25 is 5. The square root of -25 is 5I. Right? So let's remember that. Okay. All right, so now we're going to take out our calculators. What I want to show you is this. Look, traditionally in your calculators, if you had plugged in -25 and hit enter, you get this answer, right? Yeah, watch. You can change your calculator so it'll do more functions. Everybody, take out your calculator and hit the mode button right there. Scroll down until you get down over here. You want it to calculate not just with real numbers, but with imaginary numbers as well. So we're going to give it a whole bunch of features. Hit enter on it, make it highlight. Now go back to your home screen, type in the thing that I gave you, square root of -25, and oh snap, just gives you the answer. Max, what's this? Do you need your calculator? Could you do this in your head? What is it? Yeah, 6I. Good. Of course, what? What do I always say? And then things get more difficult. It's never that simple. It's never that simple. And this is more because, well, the calculator has limitations. The calculator has limitations. So the calculator, like many students, freaks out when it sees an irrational number. Let's type this in. It's ridiculous. Calculator bugged out. It BTFO'd. Get it? It's funny. Anyways. I know. I think it's funny. Anyways. So the calculator bugs out. That's not the answer. Don't write that down, please. Okay, you're going to have to attack these problems the long way. But we can still use our calculator to check our answers. You could also use your calculator if you were given multiple choice. So whenever you're given questions like this, what do you do first? You take out the I and you break it down, right? What's 8 break down to be? Yeah, that's square root 4, square root 2. And then this becomes 2I square root 2. That's it. That's what we do. So we got one more problem that I would like to take a look at. That's what happens when we stick a negative out in front. What do you think? Nah, man. Yeah, you do the same thing we've been doing. Break out the I, so there's like a negative times I, and that's all right. And then you just break it down. Break it down. Square root 3, and so it becomes -2I square root 3. Now that happens to be that I write with the way that I write these. You know. Okay, let me put a square around this. I tend to always put a box around my answer, or try to. It's good to have it. So we're in part 2. We're going to, of course, you're going to have to simplify like adding and subtracting them, but this is a piece of cake, right? Check it out. You're the man. Not -12I, but like, what's the square root of -25? What's the square root of -49? What's 5I plus 7I? You know, you could do that in your calculator too. All you'd have to do is just punch it right in. Right? What do you say if when you can do cool stuff like this? Yeah. Yeah. It's really, whoa, I messed up. Let's talk real geeky. That's awesome, man. That's great. Check that out. No, but that's really cool, I think. I think it's really awesome. All right, guys. Next question. Have a go. Try your best. There you go. There's the answer. Okay, so let's try a really hard problem. Really hard problem. So we're gonna, that's 2 plus 3i plus 5. Anytime two things are next to each other, it's multiplication. Oh, so that's 2 plus 3i plus, guess what? 10i. And now i's work like x's, right? You can't 2 plus, we have 13 i's. 13 i's. Now here's one of these instances. I want you to memorize how this looks, because this is known as a complex number. This is known as a complex number. It's a number that has issues. Raise your hand in here if you have issues. I don't want to know what they are. Yeah, exactly. Everybody has issues. Everybody has issues. This is known as a plus bi form. So it's known as a plus bi form, and the reason I said that it has issues is because it's part real, and the real number always goes in the front, and then it's part imaginary. Imaginary goes in the back. So when I ask you, and later on I will, to put all of your answers in a plus bi form, it must look like this. If I don't say those words to you, then it doesn't matter really the order that you give it to me. But if I do, it must look like that. Okay, last part. Part three of our three-part lesson, powers of I. Guys, what did I tell you I to the first was equal to? No. See, now here's the problem. The power I to the first isn't equal to -1. It's equal to the square root of -1. Okay? And what I'm going to tell you is, I know this is confusing, that's the same thing as saying I. What about I squared? Well, I squared is really just I squared. That's the square root of -1 squared. And what happens when you square a square root? You get the stuff underneath. I to the third. Okay? I to the third, well, I'm going to rewrite these as if I were writing x's. Like what I'm going to show you is that x to the third is the same thing as x squared times x to the first. True or false? True? That is true. Okay, so hold on a minute. That's the idea that's being used here, right? I to the third, that's the same thing as saying I squared times I to the first. How much is I squared worth? How much is I to the first worth? So I cubed is really just -I. And a pattern starts to emerge. I to the fourth. I to the fourth is I squared times I squared. How much is I squared? How much? So what's -1 times -1? Okay, 1. And it's at this point I want to stop right here. We're going to keep going with this, but I want you to write something down that's really important. Remember this day of December when I showed you that pattern below. Okay. So what I want to show you is this can be done in your calculator. Everybody, look at your calculators right now. The I button is at the very bottom. It's right below the 2. Check it out. I to the first is I. I squared, -1. I to the third, and I to the fourth is 1. So you can do these in your calculator, but your calculator has limits to it, and we're going to see that in a minute. All right? So we did I to the fifth. Let's test and see if our calculator can do I to the fifth. Yep, we're still good to go. Let's try I to the sixth. Oh, that's annoying. Yes. I to the sixth is I to the fourth times I squared. That's 1 times -1, so that's -1, right? Let's do I to the seventh. Let's also check to make sure I to the sixth, I'm sorry, can be done in the calculator. I raised to the sixth. Yep, that still works, and we're right. Now let's try I to the seventh. That's I to the fourth times I to the third. What's I to the third? -I. Now let's see. And it's at this point, once you break past 7, and I can't tell you why, your calculator bugs out. But because I'm real geeky, I read the calculator manual when I got bored. I'm dead serious. I have read it. Well, the truth of the matter is I really needed it for my statistics class, which is mostly like, this is very technical. And along the way, I happened to figure out a whole bunch of random stuff. And also, I'm real geeky, and on Friday nights, this is what I do. So here's what we're going to do. Everybody remember this. This is the trick to fixing that problem. Hit the math button. Scroll over to number. Guess what we're going to pick? I part. If you take the I part and you enter it in, it automatically fixes this glitch. Do you see? It's great. It's great. Okay? So let's do I to the eighth. Well, I to the eighth is the same thing as I to the fourth times I to the fourth. Now let's use our calculators to just make sure and check this. Right? Just type it into your calculator. This means you hit the math button. You go over to number. You scroll down to I part. You hit enter. You type it in. And it's 1. Do you notice something? Take a look at the pattern. It's starting to repeat itself. I, -1, I, 1. Look at the first 4. I, -1, I, 1. And this happens in groups of 4. So now on your Regents exam, here's really the question that they ask you. They would never ask you something this simple. They would ask you something like this. Do me a favor. Now that you're so good at this, right, find for me how much I to the 101st power is. Now, I told you I would show you 3 ways to do it. The first way, the simpleton way of doing it, right? I used to teach a kid who this is how he would do it. He would literally sit there and he's like, oh, I remember it goes in groups of 4. I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. He would literally count to 101. And we all used to know that he did this. And so people in the class would randomly go like 5, 2, 7 while he was doing it. And he would get very frustrated. I highly recommend you don't take that route, okay? The other route that you could take is you could just punch it into the calculator. Let's see. Right? It's I. Whoops. Okay, that's the best way to attack this type of problem. But suppose you're a person that doesn't like using your calculator. How else could you do it? Well, and this goes back to studying for your SATs. The pattern is groups of 4. And every group of 4, it starts to repeat itself. So all you have to do is take 101, divide it by 4. 4 goes into 10 2 times. 8, bring down the 2, bring down the 1. 4 goes into 21, what? 5 times. That produces 21. And this means that there are 25 even groups of 4 and a remainder of 1, which means after you had gotten done counting through these, going like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, guess which one you would have stopped on? 1, which means I to the 101 is really the same thing as I to the first. In other words, the remainder is the number up over here that you're looking for. And so I to the first is just what? Is just I. In any event, that's all I got for you today.